Away, children. Yeah, I'm back, Tuesday. So we continue with circle geometry. Now we're gonna be dealing with finding the equation of a tangent. Right. So here's an example. Determine the equation of a tangent to the circle. So it can be tangent or tangent depending on the equation. X squared plus y squared is 25 at this point. So we'll have a circle at this point. Now what is important here is we need to know this circle here. Obviously, we said a circle that's like this. What's the center? We said it's 0 and 0. That's already covered. And then this is r squared. We know it's 25. So if I'm going to find the square root of that, which is plus or minus, this will be plus or minus 5. So which means my radius is 5 units. But notice the center from the origin, which means the center is here. So if my radius is 5 units, it means 5 units going to the right, 5 units going up, 5 units going to the left, 5 units going down. So we have a circle that looks something like this. Excuse the scale. It won't be straight, but yeah, you get the picture. So it will be a circle that looks something like this. So this circle, they want the tangent that will pass at the point minus 3 and 4. So minus 3 and 4. So there'll be a tangent that will pass here at minus 3 and minus 4. So a tangent, obviously, it's a line that goes like this and touches once in the circle. So what is important for us to always find out is work out because even from here to here, it will be the radius. Just like every part was radius here. So what is important is this radius. You work out the gradient of this radius at the point 0 and 0. So from here to here, we can work out the gradient of this radius. And then what do you know? A radius is always perpendicular to the tangent. So since our radius is perpendicular to the tangent, it means the gradient of the tangent, this times the gradient of radius will always be equal to minus 1. So let's go with it. So now let's find the equation of the gradient here. So looking for the gradient, we have the coordinates 0 and 0 and minus 3 and minus 4. So that is from there to there. So we can just work out the gradient using the gradient equation. So we have y2 minus y1 over x2 minus x1. So 0 plus 4 over 0 plus 3. That will give us 4 over 3. Then we can substitute our radius there because we have now the gradient of this radius. And then obviously to solve for the gradient of the tangent times by the inverse of this, which is 3 over 4 here, times by 3 over 4 there as well. So the gradient of the tangent is minus 3 over 4. Now we have the gradient of the tangent. So we know anytime we want to find the equation of a tangent, just like finding the equation of a straight line, we must go to y minus y1 is equal to m into x minus x1, where m is the gradient, x1 and x2, it's where the gradient cuts here. The gradient cuts at minus 3 and 4. So what's going to happen here, we're going to have a situation where we substitute the minus 3 and minus 4. So negative times negative becomes positive. Negative times negative is positive because this is my x1 and y1 where my tangent cuts the graph. Then from there, that's it. You just work it out from there. Just a matter of multiplying out, transposing. You have the equation of the tangent. It's that easy to find the equation of a tangent. Just find the gradient of the radius. Then it will give us the gradient of the tangent. Have fun.